What up, physics lovers? It's your boy back with another kinematics problem. We got a little Timmy in a ball rolling at 10 meters a second, and he's got this ball of uranium in front of him rolling at 5 meters a second, same direction, 5 kilograms. Don't know his mass, don't know what his velocity is afterwards, but we know the velocity of this one. We also know it's an elastic collision, so we can use conservation of momentum and conservation of kinetic energy. So his mass times his initial velocity, 10 meters per second, plus the mass of this ball, 5 kilograms, times its initial velocity, 5 meters per second, is going to equal the final velocity and final mass. Mass doesn't change. So his final velocity we don't know, but we know the final velocity, 7 meters per second of this, and we know its mass is still 5 kilograms. So we've got 35 newton seconds here, 25 newton seconds here. I'm going to subtract 25 from both sides. You get 10 times mLt equals his mass times his velocity plus 10 newton seconds. And then we're going to want to get one of these variables alone so that we can plug it into the kinetic energy conservation equation. So I'm going to do his mass and get it alone on one side. So I can factor out this, subtracting this from both sides. I'll get minus V sub LT equals 10 newton seconds. And then if I divide both sides by, this, we get an expression for mLt in terms of V. Now I can use that for the kinetic energies. So we'll go, where do I want to write this? Up here. 1/2, and instead of using little Timmy's mass, we're going to use 10 over 10 minus V times his initial velocity 10 squared, and then I'm going to bracket this. Yeah, there we go. And then the mass of this, 5 kilograms, this uranium, times its initial velocity squared. And then close the bracket equals 1/2. Ooh, I don't know if I'll have enough space. I probably will. And then his final mass is still 10 over 10 minus V times his final velocity we don't know. And then, oh goodness, running out of room. We'll go down here, plus the other ball's mass times its final velocity squared, and then close the bracket. To make things simpler, I can multiply both sides by 2 and get this whole thing to be just what's inside the brackets. Multiplying this out, 125 here, and then 1,000 over 10 minus V here, plus 125, and then that equals 10V squared over 10 minus V on this side, plus 5 times 49 is 245. From here, I'm going to want to subtract 125 from both sides, which gives 0 right here, and 0 to 120 right here. For even more simplicity, I'm going to write this all out over here, just so it's a little easier to read. 1,000 over 10 minus V equals 10V squared over 10 minus V minus 120. And all of these are divisible by 10, so I'll just take a 0 off of all of it. And I'm going to multiply every term by this denominator here so that it goes away from these terms and gets multiplied by this 12. So 100 equals V squared minus 12 times 10 minus V. So now I'm going to distribute this and move the 100 to the other side to make the whole thing equal to 0. So 0 equals v squared minus, here we have negative 12 times 10 is 120, and then negative 12 times negative v is positive 12v, and then minus 100. So then, no, sorry. Yeah, okay. This is supposed to be plus 120. Oh, yeah. Okay, so I missed this sign here and this sign here. It's resolved. So now 120 minus 100 is 20. And so I can rewrite this as the two factors, v minus 10, v minus 2. And that makes it a little easier to see. So v has to be 10 or 2. But looking back at this expression for mass, if v is 10, then it's going to be 10 Newton seconds divided by 0, and that's not going to give us anything useful. So we don't want this term, we want this one. So the final velocity of little Timmy's ball is 2. Plugging this number back in here, we get 10 over 10 minus 2. That's 10 over 8, that's 5/4 of a kilogram. So his mass is 5/4 of a kilogram. So now we have our two answers for numbers 1 and 2. We move on to number 3, which asks if the average force is 100 newtons, how long does the collision last? So you can use this expression for, or this definition of force is the change in momentum over the change in time. And we know that change in momentum is the first moment, or the initial, the final, minus the initial. And we'll do this for the uranium. So delta P is 5 kilograms times the final velocity 7 meters per second minus the initial velocity, initial velocity 5 meters per second. So that's 5 times 2, that's a change in momentum of 10 Newton seconds. Now if we plug in the 100 newtons for the force, we get 100 newtons equals 10 divided by delta T, and then multiply both sides by delta T and divide both sides by 100. Delta T is equal to 1/10 of a second. So the collision lasts for 1/10 of a second. This next question, number 4, asks for the rate of change momentum. Rate of change momentum is just defined as force because it's the change in momentum over the change in time. So all you have to do for this, it's 100 newtons as defined up here, so it's 100 newtons to answer this question. After the collision, it asks how long will it take for them to have 50 meters between them. Little Timmy's ball is going 2 meters per second, and the uranium ball is going 7 meters per second. So every second, 5 meters of distance, they move apart 5 meters. So there's a 5 meter per second velocity between the two of them. So we want 5 meters per second times some number of seconds equals 50 meters. Divide both sides by 5. Get the time to be 10 seconds until they are 50 meters apart. Finally, we want the how long it would take, what the K constant of a spring would have to be for it to stop the uranium ball in a distance of 1 meter. So the potential energy of the spring, 1/2 K delta x squared, delta x is 1 meter, equals the kinetic energy of the uranium ball, which has a mass of 5 kilograms and a velocity of 7 meters per second. And then we square that. This whole expression, when you multiply everything out, is 122.5. and that equals 1/2 k times 1 meter squared. Multiplying both sides by 2, k times 1 equals 245. So k is 245 newtons per meter to stop the ball in a distance of 1 meter. After that, that's all the questions. We're Gucci gang. That's it.